Alright, in a previous video we talked about the corrosion of iron, and that's where iron's being oxidized. So to prevent corrosion, we have to prevent iron from being oxidized. And we can do that physically, and we can do that by chemical means. But let's first of all look at the conditions that promote rusting and see how I tried to make that a rust color. So we know that iron, oxygen, and water must be present for rusting. If they are able to come in contact all together, the amount of rusting is going to increase. And if we have electrolytes, things like salt, sodium chloride, if that's around, the rusting also will increase. So if we want to prevent corrosion, and corrosion of course costs economies billions, millions of dollars as things wear out and have to be replaced, we've got to prevent the interaction between iron, oxygen, and water. So physical barriers, we're talking about not using chemical reaction to protect, we're talking about physical barriers, ways of just physically blocking these things from getting together. So if you've got some iron metal, some steel, you can use some kind of paint designed for metal to coat it. You may coat with oil or grease. Oil is water repelling, so it wants to keep the water away, and it can be a barrier even to oxygen getting there. The electrochemical techniques are a little bit nicer. And what this involves is protecting one metal by connecting it to a more reactive metal. And so what that means is on your table of reduction potentials, you look at iron on the right, and any metal that's below it, you could use to protect it, because that other metal will oxidize before the iron. Now you'd be careful about hooking up sodium to it, because if you have water present, it would catch on fire. So you want to choose a safe metal that could do the job. So in other words, we're protecting the iron, we're forcing the iron to be the cathode. And anytime you have a cathode, the only thing that can happen there is reduction. There's no chance of the iron oxidizing because it can't be the anode. So the more reactive metal is the one that's going to be sacrificed, the one that's going to wear away. So common way is to connect it to something like zinc or magnesium. But let's talk about zinc. Zinc will be called the sacrificial anode. A small amount of zinc there, the zinc will get oxidized, it'll wear away, but our iron will not have a problem. It says there's a whiteboard diagram of an outboard motor on a boat, and so I'll have to make a video of that. You'll have to check it out later on. So zinc and iron, we know zinc is below iron on the right, and therefore is considered to be more active or more reactive. It wants to be oxidized, and that's what protects it. So zinc, chromium, aluminum, magnesium are all below iron on the right side of your table of reduction potentials. So they can all be used if they're connected to, directly attached to the iron. These metals wouldn't work. They're all above iron. So in fact, if you connected those metals to them, they would increase the rate at which the iron rusted. So definitely don't want to do that. That's it for that video, and we're going to look at galvanizing in a little more detail in our next video.